I'm going to work these next couple of sections pretty quickly because they're things that we spent a lot of time lately. And section 6 is on representing proportional relationships. And so Bridget's new car uses 4 gallons of gas to travel 184 miles. How far does she travel if her car used 10 gallons of gasoline? There's a couple different things you could do. What I personally would do is if she can go 184 miles, oops. Why did that just stop working all of a sudden? All right, if she can go 100, sorry about this, guys. Pen, there we go. If she can go 184 miles on 4 gallons of gasoline, if I take that 184 and divide it by 4, that'll tell me how much she can travel on 1 gallon of gasoline. So 46 miles is how far she can travel on 1 gallon of gas. So the question is asking us if she used 10 gallons, how far did she travel? 46 times 10 will give us 460. Number 22, Ben typed 250 words in 2.5 minutes. What is his typing rate in words per minute? Of course, per means 1. So if you can do 250 words in 2.5 minutes, just do 250 divided by 2.5 or 2.5, whatever you prefer. You are going to end up with 100. So that means that he can do 100 words in 1 minute. So 100 words per 1 minute is your answer. 23, if an initial rabbit population of 175 increased by 20%, what is the rabbit population now? So first of all, we've got to figure out how much it went up. So 20% of 175, this is something that we should recall from 7th grade. Remember, 20% you need to turn into a decimal, so it's 0.20. Of is a code word for multiplication, 175. So just put in your calculator 0.20 times 175, you'll get 35 for your answer. Now 35 is not the actual answer to this question. It says it increased by 20%, so this is how much it went up. So we need to know, though, what the rabbit population is now. So we have to take that original 175, add the 35, that gives us a total of 210. Number 24, it says complete the proportion. So it's kind of like we're unsimplifying a fraction. So if I could figure out what I multiplied that 14 by to get 35, I can multiply 25 by that same number in order to get x. So if I do 35 divided by 14, I'll see that that gives me 2.5. So that means to go from, and I'm going to actually rewrite this down here a little bit to make it a little bit bigger. Remember that a proportion, it's just like a fraction where you have to multiply the top and the bottom by the same number. So 35 divided by 14 gave me 2.5. That means that 14 times 2.5 is 35. So if I take that 25 and multiply that by 2.5, that'll give me my x, and it turns out that that is going to be 62.5. So 62.5 is my answer. Our next section is rate of change. We have talked about this a ton. So just like the last section, I'm going to do this pretty quickly. It says the graph below shows the time and distance for a car trip that Sarah took this summer. Tom also took a trip this summer, and the equation y equals 45x shows the total number of miles y that he traveled in x hours. So this one is Tom's summer trip, represented by this equation. This one is Sarah's. So which statement is true? Sarah's car is traveling at a faster speed than Tom's. Okay, that speed is going to be miles per hour. In other words, how many miles are they traveling per hour? So we need to figure out which each person's rate of change is. That means every hour, how many miles did they travel? We've talked in previous examples in earlier videos how this number in front of the x is your rate of change. This is also Tom's speed because x is the number of hours and y is the number of miles that he travels. So every hour he travels 45 more miles. So his rate of change, or also his speed, is 45. So now we need to figure out what Sarah's speed or rate of change is. Now I could kind of estimate using this one right here that kind of falls in the middle, But I'm going to actually pick these 2 points right here that hit in the corner, because I know for sure that this is right here at the 100 mark. I know that this is at the 0. So if I go over and then I go up, so this went up 100, it went over 2, so her rate of change is 100 over 2, which means her speed or rate of change was 50 miles per hour. So Sarah's car is traveling at a faster speed than Tom's. I'm pretty sure that's right, but let's double check and make sure none of the others are right. Tom's car is traveling at a faster speed. Nope, because he's 45, she's 50. Tom's car and Sarah's car are traveling at the same speed. Nope. Tom's car and Sarah's car are not traveling at a constant rate of speed. Constant rate of speed means that every single hour they're traveling the same amount. The fact that hers is a straight line means that she has a constant rate of change. So she's driving at a constant speed, and he is also driving at a constant speed, because this tells you that every single hour it goes up by 45 miles. So that can't be right either. So we're going to stick with A. Sarah's car is traveling at a faster speed than Tom's. Number 26, which one is true? So here's Sarah's trip again. For each day of driving, Sarah drove 50 miles. Okay, so here she is at the 50-mile mark, because this is miles right here. So each day of driving, well, no, this is after each hour of driving. So after 1 hour, she's driven 50 miles, not a day. So that can't be right. Each mile of driving took Sarah 1 day. No. This table doesn't even tell you how many hours are in a day, because there's like 24 hours. This is all about hours and miles, so forget about this day stuff. Each hour of driving, Sarah drove 50 miles. Well, 1 hour of driving, here's 50. 2 hours of driving was 100. 3, it's 150. This seems like a contender. Each mile of driving took Sarah 50 hours. Well, that doesn't even make sense. Okay, that's just backwards. They got the miles and the hours backwards. Each mile of driving did not take her 50 hours. So the answer has to be C. 27, the airplane climbs at a steady rate. This is also our rate of change. The illustration below shows the rate at which the airplane climbs. So every time it's going up 1,000 and over 1,500. Up 1,000, over 1,500. What is the equation of the line that represents the airplane's height above the ground after takeoff? So remember that the number in front of the x is your rate of change in an equation like this. Rate of change is your change in y, so you're up and down, over your change in x. So 1,000 over 1,500 is going to be your rate of change. So 1,000 over 1,500 simplifies to 2/3 x, because if you divide 1,000 by 500, you get 2. If you divide 1,500 by 500, you get 3. So that means it is going to be that one right there. Last but not least, which one has a higher rate of change between this one and this one? The number in front of my x is my rate of change, so that one is a 1/2. Now to find my rate of change from the table, I'm just going to pick 2 points where it hits right in the corner. I'm going to pick that one and that one. I'm going to draw my little imaginary triangle. So it went over 1, 2, and then it went up 1, 2, 3, and 4. So my rate of change, remember, is my change in y over my change in x. 4 over 2 simplifies to a 2. So the graph is higher. And my evidence here is enough. I've got proof here that my rate of change is 2, and that one's only 1/2. So the graph has to be higher. Okay, my next section is all about slope-intercept form of an equation. Now this is definitely our newest concept, but it's really not too terrible. Okay, slope-intercept form of an equation, remember, looks like this. Y equals mx plus b. I don't know who the guys are as a math teacher. I know I should know this. They use the letter m to represent the slope, otherwise known as your rate of change of your line. The B represents your y-intercept. So if it's in this format, you'll always have a y by itself, then the number in front of the x will be your slope, The number at the end is going to be your y-intercept. That's why it's called slope-intercept form, because it gives you the slope and your y-intercept. Again, remember that slope is also the same thing as rate of change. So let me find my y-intercept first. Remember, your y-intercept is right there where it hits the y-axis. This is where the graph comes in contact with your y-axis, and it looks like it's down at -3. So your y-intercept is -3. So it's going to be y equals some number in front of the x minus 3. So now we got to figure out what the slope is. So I am going to pick 2 points where it hits in the corner. And be careful, because I did this the first time too. This one almost looks like, it kind of looks like it's hitting in the corner, but really that one is the one that's hitting in the corner. And then of course that one is hitting right there in the corner. So if I count to move from here to here, I have to go down 1, 2, 3, 4 places down, and then 1, 2, 3, 4, 5 places over. So that means my rate of change is going to be 4/5, and because as it's slanting downwards, it's a -4/5. So my slope is -4/5, my y-intercept is a -3, so my equation in slope-intercept form is y equals -4/5 x minus 3. Number 30, find an equation whose slope is -3/5 and whose y-intercept is 2. We really don't even have to do any work for this one. It's simply going to be the one where we have a -3/5 in front of the x. So this is a +3/5, so that can't be it. That's a +3/5. If the y-intercept is a +2, this can't be it because that's got a -2. So it has to be C. Number 31, we're looking to see which one of these graphs has a y-intercept of 3, because that's our y-intercept at the end. Which one has a slope of 4/5? So first of all, let's find the y-intercept first. This one hits the y-axis at a -3. So that can't be it, because our y-intercept is a +3. This one also hits at a -3. So that can't be it either. I can really just tell by looking. I don't even have to do the rate of change because this is a +4/5, which means I'm looking for a line that's slanting upwards from left to right. So it's got to be C, but let's also just double check our rate of change too. So I've got this one, and I'll pick this point right here. So it went over 1, 2, 3, 4. Oh, wait. No, sorry. 1, 2, 3, 4, 5. Yeah, it went over 5 and then up 1, 2. Wait. 1, 2, 3. Wait. Is that right? Hang on. So I've got a point there, and I've got a point there. So 1, 2, 3, 4. Oh, 1, 2, 3. You know, there's actually a mistake on here because this actually only has a slope of, unless I'm just not picking my points right here. Let me see. No, that one's definitely hitting at the corner, and that one's definitely hitting at the corner. So over 1, 2, 3, 4. Yep, and up 3. Yeah, there's actually a mistake on this, guys, because it actually goes up 3/4, not 4/5. But this one's still the one that it has to be because, so, you know, sometimes there are mistakes on tests. Apparently there's a mistake on this practice test. Sorry about that, guys. So if you were going to narrow it down to the best wrong answer, it would have to be C because it's the only one that's slanting upward with a positive, and that also hits at the 3. So we're going to assume that that's what the people meant to be the right one. And number 32, it says graph the equation y equals -x plus 6. So our y-intercept is a 6, so we know we're going to have 1 point right here at the 6. Now we got to figure out a rate of change in order to get the other points on the graph. Remember that when there's no number in front of the x, that technically means that there's a 1 there. We just don't write the 1 because in math we like things short and sweet as possible. If there were just an x, there would technically be a +1x. But because it's a -x, that means our slope is a -1. That's the same thing as a -1/1, because -1 is the same thing as a -1/1. So from here, that means we're going to go down 1 and over 1. Down 1 and over 1. Down and over. So then I will connect my dots. Add my little arrows at the end because I could technically keep going forever and ever and ever if I chose to do so, but who wants to do that? So I have a y-intercept of positive 6, and it's landing down 1 and over 1, down 1 and over 1, which is a 1 over 1. So that is the graph of my equation. The last section has some special cases, and this is our most recent thing that we've learned in class. What to do when you don't have every other function we've graphed so far, or I shouldn't say function, every equation we've graphed so far has an x and a y in it. This time I only have an x. What that means is that no matter what, your x value is always a negative 3. So let's look over here at where the x is a negative 3. So that means in every single case, your x, your points always have to be right here where the x is a negative 3. So in order for that to happen, it's got to be a straight line up and down like this. So this one, for example, is a negative 3, 2. This point right here, for example, is over 3 and then down 1. So it's a negative 3, negative 1. So and all these lines, all of them on this line, the x value is a negative 3. So if it's an equation where x equals anything, you're going to find that value for x, and it's going to be a line that goes straight up and down through that value along the x coordinate. What is the slope of the line? Remember, we talked about a couple of special instances, and this is one of them. When it's a straight up and down line, we have to find the slope. Remember that it's your change in y over your change in x. So if I wanted to find my rate of change from this point to this point, I go down 1, 2, 3. So this would be a negative 3. And I don't travel left or right. I stay the same. Remember, we talked about this in class, that you actually can't divide negative 3 by 0. It's a divide by 0 error. So because you can't do negative 3 divided by 0, the slope is what we call undefined. That means we don't have a math term to explain what this slope means. So we're just going to say that it's undefined. In another special case, this time instead of an x equals something, we've got just a y equals something. So now that means that in every single case, the y has to be a 5. So we're going to go right up here to where the y is a 5. And that means that in every point on this line, your y value has to be a 5. So instead of it being, and that wasn't a very straight line, sorry about that. So instead of it being up and down, like our last example, going through where x is equal to 3, now it's going to go straight across where y is equal to 5. So this is what the graph would look like. What is the slope of the line? Well, remember, it's your change in y over your change in x. So our change in y, we don't go up or down. If I were going from like this point to this point, we don't go up or down, so it's going to be 0. But we travel 1, 2, 3, 4, 5. 0 divided by 5 is 0. Don't get that confused. Okay, now you can't divide a number by 0, but you can divide 0 by a number. So in this case, the slope is flat, which is a 0, but in a case like this, when it's straight up and down, it's undefined. So don't get those backwards. So again, here, your slope should be a 0. And if you think about it in real life, that makes perfect sense. If you've got a perfectly flat street, what's the slope? Well, it's a 0.